On my next example, I have the square root of 72. The square root of 72 is not a perfect square root. So I'm going to break it down into 8 times 9. 8 breaks down into 2 times 4. 9 breaks down into 3 times 3. 2 is prime. 4 can be broken down into 2 times 2. 3 is prime, and 3 is prime. I have a pair of 2's and a pair of 3's. The 2 comes on the outside, the 3 comes on the outside. They are multiplied together, and this 2 will stay underneath the square root. 2 times 3 is 6. On my next problem, I notice I do have a perfect square. So I'll just carry the 5 along, and I'll multiply it by what's the square root of 49, which is 7. 5 times 7 is 35. The square root of 3 just is going to be carried along. I will break down 28 into 7 times 4, or 4 times 7, and 4 breaks down into 2 times 2, and the 7 stays a 7. I have a pair of 2's that come on the outside, and the square root underneath it still has a 7. The negative 3 comes down out in front. You multiply those together. That gives you negative 6. The square root is 7. The square root of 40 can be broken down into 4 times 10. 4 is 2 times 2, and 10 is 2 times 5. I have a pair of 2's. 2 comes on the outside. 2 and 5 stay on the inside. The 6 comes down and is on the outside. Multiply these together, you get 12. Multiply the 2 and 5 together, you get 10. Now for a couple more challenging problems. When you have the fractions and they're both perfect square roots, those come out really nice and neat. We get 5 over 3, or plus or minus 5/3. The next one, we've got 4 over 7, or plus or minus 4 over 7. Both of these are perfect squares. In my next problem, I do not have perfect squares, either one. But since they're both underneath the square root, I can actually divide these numbers together. 15 divided by 5 is 3. Or we could say this becomes a 1 and this becomes a 3. Divide each of them by 5. So I end up with the square root of 3 over the square root of 1. The square root of 1 is 1, so really I just had the answer, square root of 3. On my next example, I will first look. I do not have any perfect square roots, but I know 8 divided by 2 is 4. So the square root of 4 gives me the perfect square root answer of 2. And technically I should put plus or minus out in front on each and every one of these problems. On my next problem, neither one of these are a perfect square root. However, 3 and 27 share like factor of 3. So on the top I end up with the square root of 1, and on the bottom the square root of 9. The square root of 1 is 1, and the square root of 9 is 3. So my answer is plus or minus 1/3. My next problem, I need to make a factor tree. 9 times 3, 3 times 3. I have a pair of 3's. That comes on the outside, and the 3 stays on the inside. So all I did was change the square root of 27. Now, these can each be divided off by 3. So 9 divided by 3 is 3, and 3 divided by 3 is 1. I don't need to write the 1. I can just simply put the square root of 3. My last problem here, the square root of 8 can be broken down into 4 times 2 and 2 times 2. Here's my pair of 2's. They come on the outside. This 2 stays on the inside. 4 plus this. Each of them divide off.